Hello. Today I wanted to talk about hybridization and why hybridization is important in organic chemistry and for possibly the MCAT. Hybridization, it contains sp3, sp2, and sp hybridizations. Um, uh, Whenever you see this in class, you're going to probably be asked, um, where are the sp3 carbons? Or you can be asked, where are the sp carbons? You're going to be asked to give the location of the hybridization points. Sometimes though, we fail to really understand the main point of why we learn or why we understand what hybridization is, and the reason why is because it allows us to understand how that carbon, that sp3 carbon, will interact with the adjacent hydrogen atoms or carbon atoms around it. You know, I'm not gonna give you why it's called sp3, why it's called sp2 or sp. I'm just because honestly, it's probably not that important in understanding the general idea of what we need to know for possibly the MCAT or something else. So this is a little chart I wrote out for you, and you can pause it, you can copy yourself, you can analyze it yourself. Probably contest me if I'm wrong, but I didn't want to go over this because I wanted to save some time. So with sp3, it's tetrahedral, but what I wanted to just tell you is just give you some examples of what an sp3 carbon would look like. So assuming that we're only looking at the central atom, an sp3 could be something as easy as, if this is our central carbon, then it's connected to 4 bonds, all single bonds. This is going to be an sp3. Okay, this one over here is going to be an sp2 because it is connected to 3 places, and it also contains 1 pi bond. If you forget what a pi bond is, basically a pi bond means any bond that adds to a single bond. Okay? So just so that you know that, in case you sort of forgot what a pi bond is, because I know I have written here no pi bonds, only 1 pi bond, 2 pi bonds. I don't know if you remembered it this way, but this will definitely allow you to understand it a little further if you sort of don't understand fully what a pi bond is or what hybridization is. And then with linear structure for sp, and the thing here is it has a triple bond or 2 double bonds. Well, first let me give you an example of what a triple bond is. Remember, this is our central atom. This right here. Oops, that's not right. That can't happen. My bad. This right here. This carbon is considered an sp carbon because it has a triple bond. Okay, and you're probably asking, oh, is this a sp carbon? Sure, it is, because it's connected to the double bond, or my bad, the triple bond. And you're probably wondering again, okay, so how do pi bonds work? Well, notice here, how many pi bonds do we have on this end? We have only 1 pi bond, right? We have this pi bond. For this one, how many pi bonds do we have? Well, our definition says pi bond is any bond that adds to a single bond, right? So that means that this adds onto a single bond, and this adds onto a single bond. So we know that this is going to have 2 pi bonds. 2 pi bonds. So that means it's going to be an sp structure, okay? Also, just so that we know, if we have this, okay, this is going to have an sp because, look, right here it has a pi bond, and here it has a pi bond, so it adds up to 2 pi bonds, right? But this carbon here is going to be sp2, and as well as this one, because they both add up to 1 pi bond on this carbon because this is a single bond, single bond, single bond, and then a pi bond on this that it would be adjacent to. So from here we can I'll just we can drill probably just really short, name all of the sp3 sp2 locations. Okay, so let me draw out a molecule and then we can go from there. Okay. Now you can pause it and then you can name all of the sp3, sp2, and sp hybridizations yourself. So basically, all of the sp3 are going to be this one. This is going to be sp3. This one's going to be an sp3 right here. Probably. Let's see, 1, 2. Okay, I think those are all of the sp3 carbons that we can find. So this is sp3, and that is sp3. Okay. All the sp2. Now, basically, you can either say, okay, find all of the. Remember, we're only looking for the carbons. Find all of the carbons that have a pi bond connected to that carbon. Okay. Well, let's see. This has one, and we find pi bonds here too. So so we can say this one, this one, this one, this one, this one, and that one are all sp2 hybridizations, as well as this one. Okay, and I'm sure you already knew that. I'm just trying to make sure that everyone is on the right track. Now find all the sp carbons. There aren't any, right? I actually didn't draw any, but I'm sure you already know what sp is going to look like. This is a really important molecule, right? This is probably something you're going to have to know for the MCAT, but don't worry, it's actually a lot easier than you think after you get the hang of drawing all of the molecules. I had to remember it. So this is tyrosine. Okay, it is a nonpolar molecule. And wait, but you're probably asking me, oh, I see polarity sides, right? I see hydroxide here, which has an inductive effect. I see inductive effects being pulled by this benzene ring. And I see inductive effects being pulled here and here, right? Thing is that we're only going to be looking at this R group region, all right? For the most part, yes, it is nonpolar, but we can say it's polar. So predominantly, we're going to remember that tyrosine is a nonpolar / polar, and you can probably slap on aromatic amino acid. Okay. All right. Now, where do we go from here? The main point I wanted to get to with sp2, sp3, and sp hybridizations is that it changes the electronegativity. The carbons that are sp3 have a different electronegativity than those that are sp or sp2. Okay, and you're probably wondering, and you're probably assuming intuitively that sp3, sp2, and sp are going to all equally increase or decrease by its name, right? Assuming that sp2 is going to be the medium of both extremes, right? So let me give you an example. This molecule, if you remember, a carboxylic acid connected to a benzene. I think it's a benzoic acid, actually. Benzoic acid. It's going to have inductive effects being pulled this way this way, and this way, right? I'll explain this arrow in a second. Due to the inductive effects, the positive charge here is going to increase, and increase by the amount of inductive effect pulling it this way to certain degrees, right? The magnitude of the inductive effect is so strong. The electronegative pull from this oxygen is so strong that it pulls all of the electrons from the hydrogen away, making this eventually turn into a H+, right, within the solution, along with this, a benzoate. I'm pretty sure it's benzoate. So now let me just take a step back and remind you what the importance of this is. With sp3, I just want you to remember that it has the lowest electronegativity. Okay? Honestly, from here, I want you to try to deduce why you think sp3 has the lowest electronegativity. Okay? You could be wrong, you could be right, but the important thing is that you're thinking in your own terms. Okay? You're thinking why something happens through the knowledge that you have in your head. Okay? This is the first step, personally, I think, to being a good scientist over a bad one. You're not memorizing, you're actually just asking why instead of what. You're asking why is this happening instead of how does this happen or what is happening, and finally just truly getting the answer for yourself. Okay, eventually over time you can Wikipedia it and you can figure it out yourself. But the importance is that you're actively trying to understand why this may be the case. Why does this have the lowest electronegativity? So sp2 has medium electronegativity, and sp has the highest electronegativity. That means, what does that mean? That means that each carbon, right? Each carbon here has, even though they're the same carbon, in the periodic table, they have a certain fixed electronegativity for that carbon, right? That's actually wrong, That's only to a certain degree that it is that way. This carbon has a different electronegativity than this carbon, okay? And that, I think, is the most important part of this lecture, understanding that. So, once again, how do you think this will change the acidity? Okay? How do you think this will undergo change to become this, CH3, compared to how this right, would become this, or how this can become this. Okay? And basically what I'm saying is this has the the lowest pKa, and this is the highest pKa. Okay? That means that this is the most basic, remembering that higher pKa is higher basicity, whereas the lower pKa is the higher acidity. So, what I want you to do is just on your own time, just imagine why you think that's the case, and then later on, if you really want to know, you can ask me, and then I'll tell you. But since I only have 15 minutes of time, this is as far as I can get. So, yeah. Thank you.